Hey guys, welcome back. Today we're going to discuss the split damage system design and implement a simple version of PreGameplayEffectExecute. The PreGameplayEffectExecute method may seem simple, but I consider it to be the most important design choice in your game. If you get it right, your game might be good. If you get it wrong, your game will be bad. This may sound like hyperbole, but it isn't. The formulas you use in your PreGameplayEffectExecute will decide how strategic the combat is in your game. If your combat is too simple, players will master it within minutes and feel like they have no need to continue playing. By building the right depth of combat strategy into your PreGameplayEffectExecute, players will keep honing their skills in their attempt to continually improve. We'll discuss this more in a future video, but first, let's talk about the split damage system. In a split damage system, we split the total damage formula into two parts: damage done, which comes from the attacker, and damage taken, which happens on the defender. By splitting our damage formula into damage done and damage taken, we calculate the damage done on the attacker and the damage taken on the defender. This works well because the attacker has most of the attributes needed to calculate damage done, and the defender has most of the attributes needed to calculate damage taken. We transfer the damage done from the attacker to the defender along with a very minimal context, such as damage element type. We can even embed the critical hit boolean into the damage value, as we'll discuss in a future video. In many cases, the entire damage formula could be handled in a single gameplay effect execute, but there is one special case: delayed damage. When damage is done at one point in time, such as shooting a bow and arrow, but damage is taken at another point in time when the enemy is hit by that arrow, a split damage system is the solution. Let's talk about damage done. In the Hub World MMO, we implement our damage done formula by using a gameplay effect execute. But you could also just use a basic gameplay effect if your damage formula is simple enough. You could also look at mod magnitude calculation to add more control over the damage done in your gameplay effect. But for us, gameplay effect execute had the right set of features. The gameplay effect execute can snapshot attribute values. This is important when the damage taken is delayed from when damage done is calculated. Some examples of delayed attacks could be ranged attacks, damage over time, or player-placed environmental damage sources. The idea here is that we want to collect the correct damage values based on the stats of the player when they initiated the damage, even though it may be a few milliseconds or many seconds, maybe even minutes later, until the defender takes that damage. And so we don't want to go at the time that the damage is taken and say, oh, go check what the stats of the player are now, right? We wanted the ones that were done when the damage was done because they need to be stored, they need to be snapshotted. In the damage done formula, we use attributes like attack, crit rate, and crit damage from the attacker. On the damage taken side, we implement our damage taken formula by using PreGameplayEffectExecute method in our attribute set. PreGameplayEffectExecute can modify the damage attribute magnitude, but it can also change the attribute type. In this method, we can also spawn new damage, healing buffs, or debuffs based on certain conditions. In the damage taken formula, we use attributes like defense, shield, and damage type resistance from the defender. The PreGameplayEffectExecute method fires after an instant gameplay effect modifies the base value of an attribute in the attribute set. It is not called on application of a duration-based or infinite duration gameplay effect, but it is called for the periodic execution that could be on those duration-based or infinite duration gameplay effect. This is important because it means that damage over time from a duration-based or infinite duration gameplay effect, we'll still call the pre-gameplay effect execute. It will still call the post-gameplay effect execute so that we get the proper functionality. We don't have to handle those with some kind of alternate method. When there's multiple attribute sets, it is called on the set that contains the attribute, just like post-gameplay effect execute. It's called once per attribute modified. So if gameplay effect has multiple attributes it's modifying, it's going to be called multiple times. And those could even be on different attribute sets. Pre-gameplay effect execute is primarily used to modify the incoming attribute magnitude, but it can also change the attribute type or create additional gameplay effects with their own attribute changes. The pre-gameplay effect execute in the Hub World MMO is only partially finished, but when we're done with it, it will have a lot of strategic formulas built into it that will hopefully create strategic gameplay. That's the goal. In the future, we will look at those formulas and that how to build strategy into that in more depth. But today, what we're going to do is we're going to use the build from scratch gameplay ability system project we've been using the last couple episodes. And we're just going to add a simple pre-gameplay effect execute that reduces the damage, the incoming damage on the defender side based on defense. So let's add that now. So first we want to come into our HW combat attribute set.h. And what we want to do is we are already overriding the post-gameplay effect execute, but we want to override the pre-gameplay effect execute, okay? And then we're going to come into the HW combat attribute set CPP, and we're going to paste in some code here. I have a little note here that this is only called on the server side. And so inside our pre-gameplay effect execute, what you'll normally see is you'll normally see some kind of if-else statement with multiple branches to it, where we're checking the incoming attribute type one at a time, right? Because we want to perform different logic based on what attribute is this trying to change. Remember, it's pre, it hasn't happened yet, right? This is before it makes the change, as opposed to post, which means the change already happened. And so what we have to ask is we have to say, was this damage? Was this healing? Was this a strength buff? Was this an HP buff, right? Was it a debuff, right? And so we have to basically, for each one that comes in, this data evaluated data.attribute will contain what attribute it is. And then we have these macros that we built that automatically generated these for us. So we have get whatever the name of the attribute name is, attribute, and that can be used to match to this type here. You see, it's an F gameplay attribute structure, right? So this will get us that matching structure so that we can do a comparison to see what it is. So basically what this says, is this incoming damage? If so, do what's inside it, right? And so later we could add other things down here with like an else if, right? We could have more things. Maybe we need to check for healing, maybe to check for other things, right? But in this, what we're going to do is we're just going to check on incoming damage. And the goal is to change the magnitude, right? So it's incoming, it has an attribute type, but it also has a magnitude of here's how much it's going to change if we don't do anything, okay? So if we don't do anything, that magnitude is what it's going to change, but this is a spot where it's giving us the ability to change that magnitude based on certain conditions. And so what we're going to say here is we're going to say, hey, get the defense. Again, this was also generated by the macros in the attribute set. We're going to say, get the defense. And again, this attribute set is on the defender. So we couldn't say, get attack and get the value from the attacker, right? Although technically this evaluated data does have a context of the person who's attacking, and we could go get it that way. But because we're using a split damage system here, it's a whole lot easier that we're just dealing with stats from the defender. And so this is getting the defense of the defender, the one who was attacked. And it's saying, is it greater than 0? And because the reality here is if it's, 0, what's the point? Now, maybe your game has the possibility of a negative defense value, and that means something, in which case you'd have to do things a little bit different. But for this test, we're going to say, hey, if the defense is 0, just skip this. But if it's greater than 0, then we need to reduce the value. And so what we're going to do is we're going to say, okay, take the magnitude, right? This is what it was going to do, and multiply it by 1 minus the defense, But be careful to clamp the defense between 0 and 1. Okay? So that means that this actually can't be 0 because of what we've got here. Well, I guess technically it could be 0. Yeah, it could be 0 but it can't be 1. But it could be 0 because we're letting it go. It could be 1 minus. It can't be 1 minus 0, but it could be 1 minus 1, right? If for some reason you had 100% damage resistance, then it would basically just negate the whole damage, which is what we would want it to do. Let's just say that the incoming defense is 10%, which is going to be represented by 0.1. So what happened here is we take that 10%, we'd clamp it to 0 to 1, which it's within, so we just stay what it is, and we do 1 minus 0.1, which would leave us with 0.9, right? 90%, 0.9. And so we would then multiply the damage by 0.9. And so what would be happening here is that we're only doing 90% of the damage that we would be doing, right? It's reducing it by 10%. So we're going to compile this and we're going to give it a try. Okay, we're going to go into our character blueprint. And we're going to first make sure that, yep, we're still printing out the health on screen. And I think we got it ticking once every 2 seconds or something. But you'll see here that we initiated max health and health. We now want to also initiate, so HW init the defense. And to start with, just to see what it would do without it, we're just going to initialize it to 0. Okay, so we can see this change. So right, so the defense is 0. If you remember from the previous, we'll go double check it. Just make sure it didn't change. If you remember from the previous, we have damage self, and it's an instant, and it does 10, right? We were going 100, 90, 80, 70. And so we should still get that same result. So let's give that a try here. Just make sure everything's still working. You can see it's printing 90. I press the key again, it's printing 80. I press the key again, it's printing 70. Okay, so it's doing 10 times. So then let's go back to our blueprint and let's give our character that 10% that we talked about, right? So 0.1. So now it's 10% defense, right? That's how we're doing it in this formula. And so what we will do is we'll run it again, and now what should happen is that it should not be exactly 10 each time. It should be less that it's doing. Here we go. You can see it's printing 100. 91, see, because that would have been 9. 82. Right? So now that 10 every time is becoming 9 because 9 is the 90% of 10. So using this method, we can create any number of rules into our gameplay effect execute to create strategic gameplay. Many times this will be based on, changing things based on buffs or debuffs. There might be shields. There might be elemental types. There might be shields based on elemental types. Things have weaknesses, and we can create all of this into it. This is something we will be doing in the Hub World MMO example project, along with the Hub World MMO example project is using reaction damage, which is just going to make everything a whole lot more complicated. Our gameplay effect execute is going to be huge. We'll probably even want to split it into multiple methods just to organize it, because there's going to be a lot there. We're going to have lots of different reaction damages. We're going to have lots of different buffs. We're going to have abilities that have special features that happen based on certain things that stack or change to try to create that strategic combat that keeps players attempting to get better at it, right? This is going to be heavily a skill-based game. This isn't a, run around, click on something, and watch and wait for it to die. It's not going to be that kind of game at all. We're going to add a lot of strategy to it, and it's hopefully going to be going to end up with the kind of combat that players can play for months and still not feel like they've mastered it. If you have any questions related to this video, please leave your questions in the comments section. The Open World server and Hub World MMO Discord link is in the video description if you want to discuss something in this video further. Like and subscribe to be notified of future videos and to help with the algorithm. Until next time, have a good one.